Welcome. The topic we will be discussing in this lecture is routing in ad hoc networks. In the last lecture, we have discussed about ad hoc networks. Ad hoc networks will not have any infrastructure. Without infrastructure, the nodes would be able to communicate. And also, we have discussed that the, the challenging part of ad hoc network is routing. So here in this lecture, we will be discussing why routing is challenging in ad hoc networks. In wireless networks with infrastructure support, that is in networks like cellular communication, the base station can always reach to all the mobile nodes. Base station is something which through which all mobile nodes communicate. Okay, all communications go to the base station. But that is not the case in ad hoc networks. The destination node may be out of range of the source node, which is transmitting the packets. So routing is needed to find a path between source and destination. Okay. So there is no fixed infrastructure, but we have to find a route. Then how will you find? In wireless networks using an infrastructure, whereas in cellular networks, there are cells. Cells are defined, and within a cell there will be a base station, and base station can reach all mobile nodes uh, without routing via broadcast. Okay, there is no routing there. Only the information should be communicated to the base station, and the base station will send the information via broadcast. And whoever the sender, only they will take the message, and then they may apply decryption and they may understand the message. Okay. Whereas that is not the case with ad hoc networks. Each node must be able to forward data to other nodes in an ad hoc network. Okay. For example, and the network will be very dynamic. It will keep changing. It will keep changing from one time to another time. It may not be same for a constant period of time. If you see this particular diagram, it shows the network topology of a typical ad hoc network at different time instances, at time t1 and at time t2. So you can see at time t1, all these nodes were connected. There are totally 7 nodes. All the 7 nodes were connected. And some of the links are good link and some of the links are weak link. If you see if you take the node n1 and n4, the link from n1 to n4 is a good link. It is strong enough. Whereas the link from n4 to n1 is a weak link. Similarly, if you take the nodes n4 and n5, the link from n4 to n5 is a good link, and also n5 to n4 is a good link. If you take n1 and n2, there is a weak link from n1 to n2. There is a weak link from n1 to n2, but there is no link at all from n2 to n1. That is, whatever the data that is transmitted by n1, that will be received by n2, but n2 cannot directly communicate back to n1. If n2 wants to communicate to n1, then it should follow this path. It should communicate to n5 and then n4 and then to n1. Okay. So like this, this is at time t1. At time 2, this network may change something like this. n7 and n6 may get totally isolated, and they have a weak link from n7 to n6. There is a strong link, good link from n7 to n6, and a weak link from n6 to n7. And all other nodes are separated. Like that, the network will change dynamically, and still you should be able to route the packets. So that is the challenge with respect to ad hoc networks, with respect to routing in ad hoc networks. Okay. So there are also other issues. What are the other issues with routing that we will discuss? The first is asymmetric links. The links are asymmetric. If node A receives a signal from node B, that doesn't mean that node B also will receive the signal from node A. Okay, it may not receive, or node A to node B may be a good link, whereas node B to A may be a weak link, or there may not be a link at all. Okay, so routing information collected for one direction uh, is is of it will not help you to identify the routing information about the other direction. Okay, but if you take many wired networks, in wired networks, the routing informations are symmetric. In wired network, in wired routing algorithms, they are symmetric. That is, if A to B, if the signal strength is this much, then B to A also it will be that much. But that not apply to wireless networks. So that we call it as so that we call that in ad hoc networks the links are asymmetric. And also the links can be redundant. Okay, okay, redundant means there may be multiple links between two nodes. In wired networks also there may be redundant links, but that is purposefully some redundant links may be added to survive failures. Okay, but there are only few redundant links in wired networks, which are additionally controlled by network administrator. So it is not. So it is consciously added by the network administrator to have more reliability on certain connections. But in ad hoc networks, nobody controls the redundancy. At some point, there may be redundant links up to an extreme of the network may become something like a mesh network. At some other point, there may not be even sufficient connections. Okay. Uh, Sometimes the redundancy in ad hoc wireless networks, the redundancy can also cause computational overhead for updating the routing tables. Okay, so this is the second issue with routing in ad hoc networks. And then there is an issue with interference. In wired networks, uh, there is in wired networks there is no interference. Okay, links exist only where a wire exists in a wired network, and connections are planned by network administrators. But this is not the case in wireless networks. Links come and go depending on the transmission characteristics. If two close by nodes forward two transmissions, they might interfere and destroy each other. Okay, sometimes interference may also help in routing. Sometimes interference may also help in routing. A node can learn the topology with the help of the packets it has overheard. If some node has overheard the packet of some other node, then it can understand the topology and it may be able to communicate with the other nodes which is not in its range. Okay, so interference has the advantage and also it has its disadvantage. It may disturb the signals and sometimes it also helps in identifying the other nodes which are beyond the range. Okay, and then as we already discussed, the dynamic topology. Okay, the topology get changed frequently. So snapshots are valid only for a short period of time. Snapshot in the sense the particular topology is only valid. The particular topology view is only valid for a short period of time. You know, in ad hoc network routing table must somehow reflect these frequent changes in topology, and routing algorithms have to be adopted. Routing algorithms used in wired networks would either react much too slowly or generates too many updates to reflect all changes in the topology. Okay, that is routing algorithms in wired networks. We cannot use the routing algorithms in wired networks for wireless networks because they will react very slowly for the changes in the topology and they will update the routing table very slowly. That may not work in case of ad hoc networks. Okay, so these are the drawbacks why we cannot use the existing routing algorithms that were present in the wired network for wireless networks. And some of the other reasons are traditional routing algorithms which are used in wired network will not work efficiently with wireless ad hoc networks, or it may fail completely and they are not designed for dynamic topology. Okay. Another reason is routing in wireless ad hoc networks not only may not only rely only on layer 3 information. It may need information from lower layers also. It may need information from lower layers also concerning the connectivity or interference. So that can help the routing algorithms to find a good path. Whereas if you see the conventional or traditional routing algorithms, they rely only on layer 3. The conventional or traditional routing algorithms, they rely only on layer 3. Okay. And centralized approaches will not really work. Centralized approaches will not really work with mobile ad hoc network, because it takes too long to collect the current status and disseminate it again. Within this time, the topology might already change. If you say this is the network status at this time, and if that information is passed to everybody, before that information reaches the network, topology may change. So there cannot be any centralized approach which says that this is the topology, so follow this routing. No, because all this happens because of the dynamic nature of the network. Okay? And many nodes need routing capabilities in ad hoc network. Okay, so the whereas in wired network there may be some nodes without routing capability. Okay, so and also for ad hoc networks, algorithms have to be considered. Algorithms should consider the limited battery power of the devices that are working in the ad hoc network. They should consume less battery power. Okay, and the other thing is uh, the cellular networks work based on connection oriented concept. That is, first a connection is established, and then the communication happens, and then they disconnect. Uh, but that cannot happen with a ad hoc network. It should be connectionless. Ad hoc network will be connectionless because it is not possible to maintain a connection in a fast changing environment and to forward data following these connections. So node have to make local decisions for forwarding and sending roughly towards the final destination. So there is an alternative approach, that is by using flooding. Flooding may be followed to to, 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 to transmit the packages. So that is the last approach we have. But the problem with flooding is, but the problem with the flooding is, it may, if the load is low, it is okay, but it will be very inefficient. Uh, but it is a very inefficient technique. So these are the reasons why we need a separate routing protocols for ad hoc networks, and why can't we use the existing routing in the wired network. Okay, the existing routing algorithms that are available with the wired networks cannot be used in wireless networks, wireless ad hoc networks. Okay, that is what we have discussed in this lecture, and what is the reason and how wireless ad hoc networks differ from wired networks, and how it influenced the routing. Right? Okay, let us stop here. Thank you.